This is Professor Ridge, and today's lesson is on section 1.6, solving linear inequalities. An inequality is a sentence with an inequality symbol, so less than, greater than, less than or equal to, greater than, equal to, or simply not equal to. Okay, so an equation has an equal sign, and an inequality would have one of these other symbols that are equals, that are not equals. So an example could be like 5x plus 3 is less than 2x plus 7. Just like with an equation, a solution to an inequality is a value for the variable that makes the statement true, makes the sentence true. So to solve, it's just like we did before, is you have to find the solution set. Principles for solving inequalities. For any real numbers a, b, and c, so we're going to have the addition principle for inequalities. If a is less than b is true, then a plus c is less than b plus c. Now this looks pretty similar to the addition principle for equations. This is pretty much the same thing. So if you add a number, as long as you add it to both sides, you'll be fine. And this is also true for a greater than statement. So if it's less than, greater than, it doesn't matter. You can add the same number to both sides and not affect the validity of the statement, whether it's true or not. Now the multiplication principle for inequalities, if a is less than b, then and c is greater than 0. So the way you should think of that is if you have an inequality, a is less than b, and c is positive, you can multiply both sides by that positive number and it'll still be the same. It'll still be true. So AC is less than BC. Now b, if a is less than b and c is less than 0, so again, if you have an inequality and c is negative, then when you multiply both sides by a negative number, you have to flip the inequality sign. So let's write that in words. So, I can summarize this. The way I think of this whole thing is you solve inequalities just like equations, with that one exception. When you multiply both sides by a negative, then you have to flip the inequality sign. Okay, so again, this is the rule you got to remember here. Whenever you multiply or divide both sides by a negative number, you must flip the inequality sign. So again, we're going to, if it's a linear inequality, we're going to solve it just like an equation. So let me give you an example. So if I had 3x plus 4 times x minus 5 is greater than 10x plus 3. Okay, so my first step is simplify both sides. So I'm going to distribute the 4. And I'm going to combine my terms. Get all the x terms on one side, so I'm going to subtract 10x. Okay, let me go up here. So I got negative 3x minus 20 is greater than 3. I'm going to add 20 to both sides. Negative 3x is greater than 23. Now when I divide both sides by negative 3, see, this is my key step here. I'm dividing by a negative, so I have to flip that inequality. Now it becomes a less than. So x is less than negative 23 thirds. And that would be my solution. Compound inequalities. Let's look at an example. If I want you to solve this compound inequality, I'm going to think of it as having 3 sides. So I'm going to try to get the x by itself in the middle, and I'm going to subtract 1 from all 3 pieces. So So if I get negative 4 is less than or equal to 5x, less than or equal to 2. And then I'm going to divide all three pieces by 5 to get the x by itself in the middle. So we get x is less than, or x is between negative 4/5 and 2/5. Now note, when you write compound inequality like this is the same as x is greater than or equal to negative 4/5, and at the same time x is less than or equal to 2/5. And so now you have to be careful because it's an and statement, so we're looking for the overlap. If I have x is greater than negative 4/5, that's going to be a solid dot going to the right forever. If I have x is less than or equal to 2/5, that's going to be, you're going to go to 2/5, solid dot, and that's going to go to the left forever. And then what we want is the overlap between these two things. So the overlap is going to be just the stuff in between. Negative 4/5 and 2/5. Okay, so it's just the stuff in between. Alright, let's try another example. Now with the or statement, then you just work them out separately and draw them both. So let me try one of those. Okay, so let's try, okay, again, I'm going to solve both inequalities separately. So I'm going to get the x by itself, so 2x is less than or equal to negative 8. Divide both sides by 2. Now notice, I'm just dividing by positive 2, so even though my answer is negative, I don't have to flip the inequality sign because it's the step I did, not the outcome. I divided both sides by positive 2, so I can just leave it alone. Okay, for the second inequality, I'm just going to subtract 5, so x is greater than negative 7. Oh, you know what? I wanted this to be positive 2. So this would be 2 minus 5 is negative 3. So x is greater than negative 3. Okay, so I'm going to graph this, and you just graph this on the same number line. You go to negative 4, solid dot, shade to the right, to the left, sorry. And then I'm going to go to negative 3, open dot, shade to the right. And that's the solution set. Now, of course, we want to put things in interval notation. We'll write it like this. Union, 3 with a parenthesis, negative 3 with a parenthesis, to infinity. Okay, so that's interval notation. Okay, that concludes the lesson for 1.6. Go to my math lab, complete your exercise there, and I'll see you next time.